Welcome to NPTEL MOOC on transport phenomena in materials processing. This course is also referred to as momentum, heat and mass transfer. This is a union of three subjects: heat transfer, fluid flow and mass transfer. Engineering disciplines such as mechanical engineering, chemical engineering and aerospace engineering deal with these three subjects in great depth. However, in metallurgical and materials engineering, these three subjects are dealt in a single course, and often it is titled as transport phenomena. The reason why transport phenomena is important for those who are working in materials engineering is because it appears in many processes and subjects that we go through. For example, in welding and in casting, iron and steel making, which form perhaps the core subjects in many metallurgical curricula, this phenomena is going to play an important role. In emerging processes such as additive manufacturing, transport phenomena also plays an important role. So, for those who are interested in going to the industry problems, this subject is going to be very important. Traditionally, this subject has been taught using shell balances which are made for each situation separately, and there are a lot of expressions that come around because of this, and often the students are left without the big picture emerging out of this subject. So, I have taken a different approach to this subject in my MOOC. What we are going to do is, we are going to take the balance equation, the constitutive relationships for that particular phenomena and the control volume approach to arrive at the governing equation. And once we have derived the governing equation, then we will start with this equation for every problem and make the problem statement, boundary conditions and limit the situation to a simple problem and then seek analytical solutions. So, by this process I expect that the students will be able to have the big picture on the governing equation and the problem definitions much better. And there is another reason because of which I take this approach. Today, performing computer simulation of heat transfer, fluid flow and mass transfer is very easy. Most of you have laptops which are capable of doing these simulations, which were hitherto done only by supercomputers, and there are a lot of commercial software which can do these. For example, ANSYS CFX, ANSYS Fluent, Star CD, FlowScience, Flow 3D and Phoenix. These are codes that are available which can solve industrial problems of high complexity. There are also very robust open source free softwares available such as OpenFOAM, which are also very mature, and you can solve a complex problem in transport phenomena. And these problems can be solved only when you have a good grasp on what are the equations that have to be solved, under what circumstances which terms will be applicable, and what boundary conditions should be applied for a given problem. And that is the reason why we take this approach in this particular MOOC. And if you want to attack an industrial application and make meaningful simulations that will be of help, then couple of electives on computational engineering, computational fluid dynamics, modeling and simulation will definitely be useful. But a very good starting point as a foundation for all this will be transport phenomena, and therefore, we are starting with a good foundation in this particular course. And at the end of transport phenomena, a student is expected generally to be able to pose a problem as a balance equation, make assumptions and render the problem as a well defined one, and then identify the geometry, boundary conditions and then simplify the problem, and then the problem comes down to a simple partial differential equation which can be integrated, and then you can get the solution in the analytical form. So, once the analytical solution is available, a student is expected to plot various parameters and interpret the solutions. So, my MOOC is going to help you in achieving these objectives of transport phenomena courses across the metallurgical and materials curricula in our country.